After summarizing all the maps and data sources, now here I'm going to very briefly overview all the Python packages and two more softwares that I've used in my 2025 30-day map challenge. As you will see, I grouped the Python tools altogether exactly 50 libraries into 5 different categories, which now we are going to overview one by one. Let's jump in. After the quick review of all the maps I prepared for the 2025 map challenge, I also wanted to wrap up all the tools I used. As you know by now, most likely since you are here, I am working in Python, so 98.5% of the tools I use are actually Python libraries. So I split them into 5 groups, and the first group, as you will see here, is about geospatial and spatial analytics, sometimes also extended by libraries which might be a bit of a stretch, for example graphs libraries, but in general they do very well in the spatial setting. So here we have GeoPandas, which is our primary tool to manipulate tabular spatial data, while Shapely is fantastic to deal with geometries in Python. So whenever we want to map anything to coordinates and geometries, which on the one hand can be drawn in a map and can be used to store spatial data and spatial data to be assigned to it, but if you also want to have it in a Pythonic way as a proper data structure, then it's Shapely. For collecting data from OpenStreetMap, my go-to tool is OSM-NX, which is a great library and wrapper around OSM combined with the network and graph analytics library NetworkX. Then, to do spatial indexing and visualize really cool and very useful hexagons, I usually go for Uber's H3. Then, whenever we're working with raster data, depending on the type and size of the raster data, I use raster.io and Rio X-ray, and depending on the computations I want to do, rasterstats also has loads of useful functions implemented. Often used just in the background, but if you want to use some unique projection, or even, for example, molvide in Python, then PyProj is a very handy tool. Then, as I mentioned, OSM-NX, here you will find NetworkX as well, but maybe don't rush that much. So Sentinel Hub is the tool set to get satellite data in a very easy way from the European Space Agency's Sentinel satellites, Sentinel mission. Now I think that there are maybe 5 or 6. Contextili is my go-to basemap library. It has a lots of different basemaps, so you can fine-tune the visuals to your taste. Where Pandana is a great tool to analyze graphs, such as road networks, if we have loads of nodes. While for more simple things, NetworkX is usually much easier and a lot more user-friendly. City2Graph is a tool I recently discovered and is really great in turning any sort of urban data into networks, while OSGeo is a collection of spatial libraries from which I was actually using GDAL in its Python wrapped version to parse large-scale raster files covering the moon. And finally, Google Earth Engine, really great too, for example, to get data from the Alpha Earth Foundation and embeddings, is also a very great tool in spatial data in Python. Then for visualization, I was using Matplotlib for the basic stuffs, as always. Then the Pillow library is really great to manipulate pictures and images, so once an image is ready, for example, exported as a PNG, even as a frame of an animation, then the Pill library will be your go-to tool to further transform it and, for example, turn it into an animation. So Pill, or the Python image library, is a great tool to manipulate or transform existing images, while the Scikit image, Sky image library, is a great tool to apply various filters on raster images. OpenCV, I was using it here to detect circular shapes, while Image.io was my go-to tool to join frames, static images, into animations. Here, Branca is a very handy tool for unique or custom color maps, while Folium, Plotly, and PyDeck are excellent tools for various interactive and 3D visualizations. Finally, to show images and load videos in notebooks, I used IPython, and I used Datasheeder for advanced large-scale raster data visualization. Then for data processing and modeling, I was using Pandas, NumPy, and Xarray for reading, parsing, manipulating tabular, raster, and numeric data, SciPy to do various scientific computations, Ether tool and collections to work and manipulate different Python data structures like lists, JSON and gzip were maybe actually their utility doubtful or like debatable, but they were just to read and store and compress and decompress files and deal with various data sources, while math contains the elementary mathematical functions we need. Scikit-learn is our standard machine learning library, and imlearn is a specific ML library or extension to scikit-learn to do predictions with imbalanced samples, which I was actually using for the building category prediction in day 5 using Google Earth data. Then system libraries, so I was using shutil for copying stuff, the IO library for writing, reading stuff, the OS library to list and read files. I was also using regular expressions, timing things. TQDM is a really great tool, so I use it in for loops all the time because it shows the progress. Very simple, but if you have loads of things or loads of iterations, it's very, very helpful to see how your iterations are doing. Then handling warnings, zipping things, naming files based on dates, and generating random numbers as usual. And a few more things. So some datasets had to be collected from various online repositories and websites. So I was using requests and URLlib to get the data. Then the previously introduced zipping comments to unzip them if needed, and beautiful soup to parse any HTML and extract the data from those unstructured files if it was needed. And finally, after introducing all these altogether 50 Python libraries, I also want to mention that I used 2 point-and-click softwares, Touch Designer for 3D generative visualization and Gephi to visualize networks. So that was it. That was all the 52 different tools plus Preview and Photoshop I used in this year's 30-day map challenge to create 30 map visualizations for every day in November. Thank you for following and stay tuned because new tutorials are coming soon to my channel. So see you there.